Hello, welcome to the presentation. The title of the paper is Examining Availability of a Packaging Unit, a Pharmaceutical Case. The authors are Mahmud, Galib and Noor Amio, Shibshankar and Faisal Mahmud from the Department of Industrial and Production Engineering, Bangladesh University of Engineering and Technology, Dhaka, Bangladesh. This paper thoroughly investigates the present availability level of a packaging unit in a reputed pharmaceuticals company in Bangladesh and finds out a practical approach to improve that availability level. Availability is one of the three factors upon which overall equipment efficiency depends. However, machine availability depends on many external factors which will be discussed as the presentation goes on. These three indices are interpreted in detail in this paper. A complex relationship between the indices were developed using artificial neural network, and then using the trained model, values of the indices were determined for desired availability values. Finally, the paper also addressed the issue if the found values of the indices were practically attainable or not. Companies nowadays are hunting for availability and performance of their production machine equipment. In Bangladesh, it is the same. Overall equipment efficiency gives information about that performance and productivity of the production process. By multiplying the values of availability, performance and quality, we can get the value of overall equipment efficiency. Availability takes into account all events that stop planned production. And on the other hand, machine availability or production uptime is the part of that active time during which a machine equipment or system is either fully operational or actual production is going on. Literature considering OEE is not so vast. Leshammer studied the OEE measure and evaluated overall manufacturing performance measurement systems. Dahl in 2012 performed a practical analysis of OEE from the perspective of Airbags International Limited. AT in 2004 implemented Total Productive Maintenance Nigerian company to improve OEE. Then there was another study done by Tejas S. Colt in 2017 regarding the reduction of machine downtime on engine cylinder block. That there are also many other techniques to improve machine availability, which includes storing more spare parts, better training of the workers and engineers, and so on. Then another study was done by Rajpal in 2006 regarding the effect of several external factors on reliability, availability and maintainability. He also used an artificial neural network to assess the model. However, their work was for the airline industry. In our paper, we have utilized their technique in line with the pharmaceutical industry. Now the contribution of our paper. In our paper, we investigate the lower availability of the packaging section and we determine the corresponding principal contributors behind those lower availability and we try to come up with a practical solution to address that existing lower availability problem. Another main contribution is that we relate the outputs from man and machine with the corresponding values of machine availability, which is a very key issue from the perspective of Bangladesh. We first did a Pareto analysis to trace the factors which were affecting the availability level in OEE. Then we did an extensive field study of the packaging system which gave us the information about the most frequently failed machine parts, and we thus discovered the main culprits for lower availability. Thus, we can see that studying a system and discovering the root causes of a pharmaceutical industry of a packaging unit is one of the main contributions of our study. We identified three external factors. Then we utilized the relevant data that were available in the company, which gave us the values of those three external factors as well as the corresponding machine availability for the last 24 months. Then, using artificial neural network, we finally search for the range of values of the external factors that can engender the machine availability values. Now some basic concept review. The first topic is overall equipment efficiency. This term identifies the percentage of manufacturing time that is truly productive. Then the concept of availability and machine availability. Availability is calculated as the ratio of runtime to planned production time. The definition that we used in this paper was machine availability equals to mean time between failure divided by mean time between failure plus mean time to restore. Then the concept of neural network, which generally consists of input and output layers and some hidden layers. These are excellent tools for finding patterns that are far too complex or numerous for a human programmer to extract, such in our paper. Now the problem description of our case study. The study was performed on the packaging unit of a reputed pharmaceuticals company. The produced medicines are in the form of tablets or capsules. The tablets, after producing the tablets are carried to the blister packaging machine. The blister packaging machine is composed of 6 sections: forming, feeding, sealing, code embossing, perforation, and punching. The machine cuts 2 blisters per stroke. Each blister contains 10 tablets. In studying the packaging of several batches of tablets, several data were taken. These data include RPM of the machine, cutting per stroke, number of blisters per cut, etc. We utilize this data to calculate the overall equipment efficiency of the machine. The resultant OEE of the current system was found to be 52.51%, which is very low. And it was found to be due to failure of different spare parts of the machine. And so we can conclude that machine related availability is the main culprit behind low value of OEE of the current system. A Pareto analysis was done to find out the main contributing factors behind low values of OEE. And from Pareto analysis we found out the causes to be motor belt problem, lack of readiness of tablets, web cap problem, improper forming, and many others. Interestingly, only lack of readiness is not a machine related problem, as it depends on the performances outside of the packaging section. Also, another interesting fact was that a few specific spare parts were liable as they occur the majority of the machine downtime. Using the 80-20 principle, we tried to find out those specific spare parts that were causing the most downtimes. And the parts in question were motor belt, webcam, and air hose liable for forming problems. We then determined the present value of the machine availability, which was only 30.84%, and the confidence level ranging from 21 to 17%. We used p-value approach to determine this value. We also used exponential distribution and log normal distribution for mean time to failure and mean time to repair, which is supported by the statistical testing of the field data. Here is the Pareto analysis that we did in our study, and we can see clearly from the Pareto analysis that motor belt problem, tablet not ready, and web clamp problem accounts for almost majority of all the machine downtimes. Now we can see that the present machine availability is very low, and this reason can be traced back to 2 broad factors: internal factors and external factors. Internal factors include machine design, machine specifications, and intrinsic properties of the blister packaging machine, which is no way a practical approach from the company perspective, because the company uses specific machines throughout the whole packaging section, which are of reputed brands. So we can easily see that we have control over only the external factors, and we considered 3 external factors: maintenance personnel index, task severity index, and daily maintenance index. We can also consider other external factors as Rajpal considered in his papers, but for our considered case the effects of those factors are assumed to be negligible. These external factors are quantifiable and directly affect the availability of the machine. In this paper, we specifically focus on improving low machine availability through these external factors. Now the first external factor, maintenance personnel index. A Likert scale was prepared to find out the value of the maintenance personnel index from the perspective of our pharmaceutical company. The index depends on three factors, which are competence, performance and availability of the maintenance personnel. The individual points from three factors are added to determine the value of this index. The highest value that can be achieved in this index is 12. Here is the Likert scale to measure competence for maintenance personnel. This Likert scale was prepared specifically for the case of our pharmaceutical industry mentioned in this paper. The continuation of the index. Then this here is the Likert scale to measure availability of maintenance personnel. This Likert scale was also again prepared specifically for the case of the pharmaceutical company mentioned in our paper. The continuation of the index. Finally, this is the Likert scale to measure performance of the maintenance personnel in our pharmaceuticals company. All these index Likert scales were prepared specifically for the case of pharmaceutical company mentioned in our paper. The continuation of the scale. Now the second external factor, which we call task severity index. Task severity index for blister packaging machine depends on three factors: no stop packaging duration, number of starts and stops during a batch packaging, and packaging speed of the machine. The final external factor is task severity index. The equation which we can see here was developed by the authors of this paper. This equation effectively quantifies the task severity issues from the perspective of blister packaging machines in packaging units of pharmaceutical companies. Besides the above mentioned two external factors, another external factor is daily maintenance index, which is defined as the ratio of total daily maintenance time to the total operation time. Generally, this index should have a value between 0.14 and 0.162. Our next challenge was to form a relationship between machine availability and the considered external factors. To build that relationship, we considered the external factors as the input variables and the machine availability as the output variable. Artificial neural network was then used to have a trained model that depicts the desired complex relation. Fortunately, for monitoring purposes, the company keeps the detailed records of when, where and how the machines fail. We have utilized those records to translate them for determining the values of three indices. Such utilization is one of the main contributions of our study, and the credit also goes to the company for having the practice of keeping track of the performance of man and machine as part of its disciplinary rules. The artificial neural network tool in MATLAB was used to train the obtained dataset. A network was developed and desired availability was targeted at least to be 60%. The corresponding values of the three indices were evaluated through several trials, and also to obtain the availability greater than 60%, how the values of these three indices change was also observed up to 95% machine availability. All these findings are shown in the below table. Here is the table showing the relationship between the desired availability and the external factors, and we can see how the external factors change as the desired availability values increase. Compared to the present values of the three indices, it will not be tough to achieve moderate availability values ranging between 0.6 and 0.75. Naturally, more intervention is required for more machine availability. But complexity may arise when the company strives for a higher availability than 0.75. For example, to achieve a high availability of 90%, the maintenance personnel index needs to be above 11. That corresponds to the fact that the personnel needs to be highly competent, excellent in availability, and exceptional in performance at the same time. This is in some cases hard to achieve and can involve vigorous training and evaluation system, and a similar conclusion can be drawn from other index values also. One important factor to note here is that although maintenance personnel intrinsically entails the effect of maintenance delay time and mean time to repair for maintenance, but the supply delay time is not directly included in this analysis. However, the unavailability, that means the supply delay, may directly hamper machine availability. How supply delay hampers machine availability is expected to disclose in our future work in the same context. The conclusion. The study demonstrates the relationship between the external factors and the desired machine availability. We determined the current availability of the system, and then we performed a Pareto analysis to find out the principal causes behind the present low availability. Also, this analysis showed that specific machine components were mainly responsible for the overall lower availability of the studied packaging section. We defined 3 external factors and we gathered their values for the last 24 months, but we should note that the values were not directly available. Their values were shaped by utilizing the corresponding historical data available from the company. Then we established a complex relationship between these external factors and the corresponding machine availability with the help of artificial neural network. The model was then used to obtain the target values of the external factors for our desired machine availability level. Moreover, the machine availability attained from the perspective of the company was discussed. In the future, extending this study, the researchers can determine the complex relationship of machine availability influenced by the availability of the spare parts too. And here are the references. Thank you for listening to this presentation. We cordially welcome any questions regarding this paper.